welcome. You're watching Agronomy and Economy. We'll have a special edition for you today. I'm Ryan Buetow, an NDSU Area Extension Specialist in Cropping Systems.
And I'm Levi Helmuth, an instructor with the North Dakota Farm Business Management Program, employee of BSC.
And today we have a special guest, Dr. Lee Manske, with the Dickinson Research Extension Center. And we'll be asking him a bit about his educational background and some of his past research today. I guess we'll get started off.
So with the educational background, you've got quite a few degrees from just visiting with you. So do you want to kind of go over your educational background a little bit with us?
Okay. Basically, I feel that in order to have an opinion on a subject, you actually have to know that subject.
Yeah.
I hate it when people have opinions on subjects that they don't know anything about. So I have attended 9 colleges. I have 15 years of college, graduated with a 4.0, and 2 years of postdoc.
Okay.
My majors are in wildlife, geology, paleo, entomology, with the emphasis on ancient environments, entomology, microbiology. My PhD is on botany, range management, ruminant nutrition, and soils. I have bachelor's in electronics, logarithmic computers, psychology, and I was the first Caucasian to graduate from the University of Ryukyu in Japanese.
Wow. Well, we got a lot to learn from you, I guess. Do you want to talk a bit about some of your past publications and some of the work that you've done?
I have taught in 5 different colleges, 6 years at NDSU. 24 years I've been teaching at Dickinson State. I've taught credits at Dawson Community College, University of Minnesota Crookston, and 1 credit in Oregon State University. Been guest lectures at University of South Dakota Brookings 5 times, and Concordia College for 10 years, 2 times a year. I've developed a grazing management workshop that I can teach in 1 to 3 day sessions, and I've taught that in Washington, Oregon, Idaho for 7 or 8 years, and with 1 or 2 weeks per year going there. I've taught it in South Dakota, Montana, 22 years in Manitoba. I've gone up twice, 2 weeks a year for a field tour, and then a weekend workshop. Saskatchewan, been 3 times. North Dakota for over 30 years. We've put more than 1,100 ranches through the workshop and giving them a 12-month pasture and harvested forage management plan at the end of that. I've worked at NDSU for 40 years now, and I have 101,657 publications. That's an average of 3.5 per month.
Wow. That's quite a few publications.
Yeah, that's good productivity.
Yeah.
So I'm always talking about ROA and ROI, and certainly 3.5 a month certainly sounds like NDSU is getting ROI from the publication standpoint.
Yeah. I guess, do you want to go a bit into some of the research findings over the years?
Yeah, when I first started, the timing of when to graze and what are the criteria, and we had no starting dates for perennial plants, and the grass was 6 inches high to graze it. So I spent quite a bit of time, found that the 3.5 new leaf stage was when perennial grasses actually become physiologically capable of handling grazing.
Okay.
And so that was pretty important.
Yeah.
And along with that, at that time, ARS at Mandan was doing work on reclaiming mine land, and they had found that, now, we didn't discover this, but most people don't know that grass tillers live 2 growing seasons.
Really?
The first year they're vegetative, the second year they can go reproductive.
Oh, yeah.
Okay.
But Dr. Langer from Great Britain actually discovered that in the 50s. He's got 3 books, and almost nobody in the United States has read it.
Okay.
And so, but he was the first one to actually find that grasses, all of the tillers live 2 years. Okay, and the Mandan ARS research found that on the second year, that the apical meristem switches over from producing leaf primordia in producing flowers. And that occurs between the 3 and the 4 leaf stage of the second year.
Okay.
Okay, and so vegetative tillers become independent from the lead tiller when they have 3.5 leaves.
3.5. Okay.
And so that becomes the point when there's 3.5 new leaves. Now, that second year tiller has carryover leaves. And those are the ones that are in the spring that are about half brown and half green.
Right. Okay.
Those are the carryover. Now, what happened this year is that we didn't have the hard frosts.
Right.
Sure.
Wow.
Yeah,
In the
it's a
spring.
milder March.
And so a lot of those carryover leaves weren't half brown. And so they looked like they were ready to graze earlier, but they weren't. There were still carryover leaves that didn't have any brown.
It has to be the new leaves.
Yeah, it has to be the new leaves.
Okay.
And so the 3.5 new leaf stage is the point of when perennial grass tillers are physiologically able to handle grazing pressure. And since grass phenological stage development is set by the length of daylight,
Yep.
we can time that within 2 days forever.
Yeah.
Okay.
Yeah.
So the starting date for crested and smooth grown spring pastures is the 1st of May. The starting date for grazing native is the 1st of June.
Okay.
The date to end grazing on native range is mid-October. And along with grazing, the number of days in a grazing month doesn't seem to be too critical. It's 30 or 31.
Right.
Okay, but that, if you use 30 or 31, you're always wrong.
Right.
Okay, so if we go on and we got leap year,
Yep.
so we have to go back to a 4-year cycle and of the grazing period. So it turns out that the actual length of a grazing season month is 30.5 days.
30.5 days.
It's
Okay.
compromise.
Yeah.
No, that's it.
That's
It's
the average, yeah.
30.47.
Okay.
Okay. So 30.5.
And so to calculate out now, to get an AUM, it's 30.5.
So is
days.
there a certain number over and under that producers could kind of graze on, or is it a
Yeah,
half day you need to?
30.5 days
Okay.
per month.
Okay.
That is an animal unit month.
Okay.
Cowboy math is a whole lot different than real math.
Right.
So,
But it kind of sounds like the conventional wisdom, though, of you brand in April, calve in the spring, and then you brand in the spring and kick out the cat. You gotta have the cows out sometime in May,
Well-
have them out on May, and then you wean and pull them off, have everything back to home in October. That's kind of sounding like it matches up with what you've said so far.
these old timers who started the beef industry in North America, without much information, really got it right.
Yeah, that's,
Okay,
but that's
calving-
not always the case. Though. I mean, a lot of time our conventional wisdom with farming and agriculture, sometimes those old wives' tales and rules of thumb, we don't always get the science right. But that's
Right, but in beef, calving in March. The calf has to be a month old on the 1st of May in order to put the weight on from the crested or smooth brome spring pasture. Grazing the summertime on native range. Now the fall is something different. We only get one type of grass that has adequate nutrition after mid-October, and that's the wild rye.
Yep.
The Russian wild rye, Altai, Basin, Mammoth, Chinese, Dahurian.
Not to be mixed up with perennial ryegrass, though, right?
Right, no, these are wild rye.
Yep.
Yeah, those names are quite confusing. And they're the only grass in the whole world that has adequate nutrition for after mid-October.
Okay.
So, I guess, what are some other things that you've looked at?
Well, when I got here, the Dickinson Research Center and Swift Current Research Center in Saskatchewan were the only two research centers that were working on complementary pastures.
Okay.
A spring pasture, a native pasture, and then a fall pasture. But they were turning out on whenever the weather was nice, staying on the crested as long as they could, and going late onto the native.
So it really varied year to year. If you had an earlier spring, you were out at, like this year, you would have been out the end of February in some places, and you maybe
They were probably not that early, but yeah, they'd have been out there as soon as the snow was completely gone. But the complementary strategy is extremely good. We need to, that's the only way to do it.
Yeah.
But the days weren't figured out. And so I spent a few years, we got the turnout for 1st of May on crested, turnout on the 1st of June for native, and then middle October we went to wild rye. Well, we started off with Russian wild rye, and Silver Smoliak from Swift Current went over to Mongolia at the Altai Mountains and actually got the Altai seed and started there. And then gave us enough seed to plant 60 acres of Altai wild rye. So Dickinson Research Center was the first place to have Altai wild rye in the United States. Wow. And Swift Current was the other place in North America that had it.
Yeah.
And that can stand up to 18 inches of wet snow. It's got stiff leaves. And so that was the advantage over Russian wild rye, because Russian wild rye is just 1 inch of snow and it's flat on the ground. Cows can't get it.
Right.
Sure.
It's a nice attribute. So how late could they graze these wild ryes?
Till mid-November. And then they also lose. But they had enough adequate nutrition so you keep the calf with the cow.
Okay.
All the way
Okay.
to...
So you don't have to wean, they wean in
Mid-November.
Mid-November weaning weight then, weaning date. All right.
One of the major problems it's taken me 40 years to do is the twice over rotation grazing and all of the factors that are involved in that. And before we got the modern high performance animal, we had these cattle that deposited really good back fat.
Yeah.
Okay. Our perennial grasses, the native grasses, the first lead tiller runs out of nutrition by the end of July. So these cattle that had a lot of back fat,
Yep.
they were producing 12 pounds of milk during the June and July. And then the grass would go below their nutritional requirement and they produce 6 pounds of milk a day on body fat.
Yep.
Okay.
Okay, now we got the high performance animals and we didn't change the forage management strategies.
Oh.
Oh, okay.
Okay, so we kept the same strategies. But now we took the back fat away from the
It's a
cow,
lean animal, lean
and
meat.
she's got less than 2 weeks of fat, and then she just dives. Okay, so that means then if she's not producing that 20 or 30 pounds of milk a day, we're not getting the genetic potential production out of her calf.
You're leaving money on the table, essentially.
Going
Right.
back to the ROI.
Yeah, the ROI that I always talk about, yeah.
And so the grasses, perennial plants, really don't use their seeds. We have many grazing managements developed to produce perennial grass seeds, but the new plants are coming vegetatively.
Right.
Okay, so I had to learn how this vegetative reproduction is triggered and how we can enhance vegetative, and those then stimulated secondary tillers have adequate nutrition, the same as the lead tiller does in June and July. So then we can get, if we stimulate the secondary tillers, we get production for August, September,
Right,
and
sure.
October.
Late summer grazing, you can kind of maintain that nutritional level.
Yeah, all the way to mid-October, and then we can't push the biology
Yeah.
past that. That's as far as we can pull it. And what that takes is when the lead tillers that are in their second year, if we remove 25 to 33% of the weight of that leaf, then we remove the inhibiting hormone auxin that's produced in the apical meristem and the young leaves.
Yeah.
Okay, then that permits the growth hormone to get to those buds. Each leaf that grows on a grass tiller has an auxiliary bud. All our leaves have 6 or 8, all our grasses have 6 or 8 leaves a year. So there's 6 or 8 buds that are capable of growing into a new tiller.
Right.
If we graze it by season long or deferred grazing, we only get one of those buds to grow for every lead tiller. We only get one secondary tiller. But if we stimulate the lead tiller in June and July by removing 25% of its weight and getting rid of that inhibiting hormone, then we can get about 5 or 6 of those 8 buds
Okay.
to grow.
Wow.
And then they're ready to graze then when they're at their 3.5 new leaf stage.
Yeah.
Okay. But this is variable,
Yeah.
okay, on how fast they get there, because it depends on soil, water, and the adequate nutrients that come from the lead tiller. So it usually takes, if we have that stimulation period is 45 days long.
Okay.
If we have 3 pastures, each with 15 days in that period, when we get done grazing the first pasture, the first 15 days, we stimulate a set of vegetative tillers.
Yeah.
It takes them 30 days to reach their 3.5 leaf
Yeah.
stage. The second pasture is a little bit drier and a little bit later. Takes them 45 days to reach the stage. And then the third pasture, which is grazed their first 2 weeks of July, it takes them 60 days to reach that. Okay, so the twice over system has 3 to 6 pastures, but the simplest is the 3 pasture system with 15 days in from the 1st of June to the middle of July. So it's 15 days, 15 days, 15 days. And then we come back and we double that. 30 days, 30 days, 30 days, and we're at the middle of October.
Right.
Okay, but that the trick is that it coordinates with when those stimulated secondary tillers
3.
are back at the 3.5 new leaf stage and ready to be grazed.
Yeah.
So we leave the first pasture, we're in the second and third pasture 15 days, and we're at 30 days, we come back to first pasture 30 days. Then we go to the first pasture 30 days. So we leave the second pasture, we're in the third pasture for 15 days, we're in the first pasture for the second time 30 days. That's 45 days that we get the second pasture stimulated. We leave the third pasture, we're in the first pasture 30 days, or in the second pasture 30 days, we come back 60 days.
So you're kind of getting your max efficiency out of those tillers.
This is, and we're giving time for that staggered length of time for those secondary tillers to reach their physiological point of where they're ready to be grazed.
Right.
So you're not prematurely harvesting.
No,
grasses.
otherwise if we graze before the 3.5 leaf stage,
Yeah.
we lose those tillers.
Yeah.
And we want those tillers, they've got the crude protein that we need to get to our high performance cows so that she can milk close to her genetic potential. So that calf then is gaining at its genetic potential.
Yeah.
Right.
This sounds. I looked at when I was back in high school before I went the whole econ route. I had attended some range day forums in Montana, and they talked a lot about the intensive grazing or mob grazing. This is kind of similar to that, maybe.
Oh, no.
Not near. As I say, not near that. It doesn't sound as intensive as that.
No,
but-
those poor guys that mob graze, the grass plants can't handle mob grazing. They're gonna be out of grass in 2 or 3 years.
I suppose you kind of have to think of the grass as not only being an above ground resource, but also as a below ground resource.
And that's traditional range management treats just the above ground plant community, not the biological requirements for individual species.
Right.
And we can't keep this ecosystem producing if we're not taking care of the biology of the plants, plus we've got to cycle the essential elements.
Yep.
Yeah.
And it takes soil organisms
Definitely.
to cycle
So it's a
those.
very holistic approach. I mean, what's best for the cow versus what's best for the grass, and not only what's best for that grass, is you got to look at the above and the below layer to get that whole
The problem
approach.
is that Alan Savory has captured the term holistic. And it's a good scientific term, but if you use holistic,
It's kind of a buzzword now, and you need to
Yeah.
be careful about. Okay.
Yeah. And so, but it is all inclusive.
Yeah.
Yep.
Okay, because you got to get the grass. The grasses actually produce double the leaf weight that it needs to survive from photosynthesis.
Okay.
Okay, that has to be an evolutionary mechanism to actually draw in grazing animals.
Right.
Okay, so the grass needs to be grazed
In order for the plant. to
in
grow.
order for the plant to be healthy.
Sure.
And it produces double the weight just to get the grazing animals to graze it. And then it's got the other half of its weight for survival.
Right. The storage of the.
Well, yeah, grasses don't store nutrients like forbs or trees.
Right. Right.
And they have to function on recently captured carbon and recently absorbed nitrogen is basically,
Jim.
okay. And the regrowth does not come from stored carbohydrates or stored nitrogen. It's got to come from, and that's why we have to leave that 67% to 75% leaf when we stimulate for vegetative reproduction,
Sure.
for it to fix that much carbon that it's going to need to produce those carbohydrates for the growth of the stimulated tillers,
Right.
because it doesn't use stored.
Yep. That's yeah. There's a lot of different components you need to be looking at, I guess, with grazing. So, I guess we could probably cover one more topic here before we cut you off for the day here. Is there anything else you'd like to cover?
The the benefits of short grass. Now, when North Dakota was picking a state grass, we picked western wheat, and so did South Dakota. It's a beautiful plant,
Yep.
produces nice. But when we've been doing research here, we know that nitrogen was, mineral nitrogen was low in prairie soils.
Okay.
I don't know when they discovered that. All of the literature that exists, they just knew it was low in nitrogen.
Yeah.
Okay, during World War II, the Germans found how to take nitrogen out of the air and make condense it, make synthetic. And so when the soldiers came back from the war and come back to the research center, we started fertilizing native range.
Yep.
And that stimulated the taller cool season grasses, increased production. We lost the short warm season grasses. Well, what that did is that those tall cool seasons are single stemmed, and they don't cover much ground.
Right.
Okay, and what it turns out that the fertilizer kills the soil organisms,
Yep.
so we're not moving the nutrients. But by losing the short warm season grasses, we opened up bare ground. Invading grasses and invading weeds backfilled. And when we follow a fertilized native range for 30 years, by the end of that, we only get 6% native grass left.
Oh,
Oh,
wow.
geez.
And it's all back invaded. The thing now, most people don't think that blue grama provides much forage, but I really think that the upland sedge and blue grama produce more pounds of beef in the northern plains than any other set of grasses. The production is density and height. Okay, but if you're covering the ground, you're not very tall,
Right.
you produce more than one tall stem that is
Right,
sparse
right.
apart. And so blue grama actually produces more pounds of herbage per acre than western wheat.
It looks like a small punch, but it's actually quite a bit more there than that one stem.
Right, and it also then it shades the ground to keep the soil temperature lower so we don't lose the soil moisture that's in the soil
Definitely.
by
Yeah.
evaporation. And we get the good production, we don't get the weeds in.
Exactly.
So we need to manage for vegetative reproduction to cover the ground and keep it shaded.
Keep the weeds out and the moisture in.
Right.
All right. I think that's all we have for you today. Thanks for joining us, and have a good one.
Thanks for stopping by.